Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. Today's topic is cracking of alkanes. Cracking is the thermal decomposition of long-chained hydrocarbons into smaller, more useful hydrocarbons. With this definition of cracking, let us take an example of an alkane, say for example a decane, and try to see what can be the possible products of cracking the decane. So now for example, I crack my decane. So the formula for decane is C10H22. Okay, now when decane is thermally decomposed, so heat will be supplied, and if I'm using a catalyst, there will be a catalyst written below the arrow. Okay, so when the alkane is thermally decomposed, you have to predict the products of the thermal decomposition. So now you have C10H22. Now if that is thermally decomposing, one of the products can be, suppose, C4H8, and since hydrogen is double of the carbon, it means that it is an alkene, and since there are 4 carbon atoms, it is a butene. So one of the products will be C4H8, that is butene. And this is my decane. Okay, so what will be my next product after I get my butene? So to find the next product, we'll do simple algebra. So from C10H22, we shall subtract C4H8, and that will leave us with C6H14. So next product can be plus C6H14. That can be a product. And what did I get there? It is having 2 into 6 plus 2 number of hydrogen atoms. So that is, it is an alkane, and this alkane is a hexane because there are 6 carbon atoms. Okay. So this can be a product. It is also possible that this decane C10H22 can break into something else. So upon thermal decomposition, again heat, catalyst, the products can be different. It can be C2H6, and this is an alkane, and this is ethane. So simple algebra to find out again about our remaining products. So you have basically C10H22 minus C2H6, so you get C8 and H16. So now the other product can be C8H16. Again, hydrogen is double of your carbon, so therefore it can be the octene. Okay, it is also possible that instead of the octene, it can further break down into 2 simpler products. So that way there are n number of products that are possible with a given alkane. So you can't just say that whatever one product is mentioned in your chemistry textbook or whatever resource you're going across, that is the only possibility. No, whenever you crack an alkane, it is possible to get a large number of different kinds of products. Okay, so I hope you're clear about the products of cracking alkanes. So this method can be applied to any alkane. Now, a very important thing is you should be knowing to write down the products of cracking ethane. So when ethane is cracked, so cracking ethane, why am I saying it is very important? Because in the Haber process there are questions. How is hydrogen obtained? So hydrogen is obtained by cracking ethane. So you have ethane which contains C and C, that is, it contains 2 carbons and there are 6 hydrogens. So you have 6 hydrogens around it. So this is your ethane, and when ethane is cracked, it is thermally decomposed. What happens is that these 2 carbon atoms over here, for example, they might be the ones that are getting lost. Ideally their hydrogen from anywhere around can be lost, but suppose these are the 2 hydrogen atoms that are lost. So that case what remains is C, and now there are only 1 2 3 4 hydrogens. So one will be here, another one will be here, then another one will be here, and one more. Now carbon needs to have 4 bonds, so 1 2. So now the molecule that is formed is said to be ethene, and what you get here is hydrogen gas. So this is the hydrogen gas. So in the Haber process they ask you often, how is hydrogen for the Haber process obtained, or how is the raw material hydrogen obtained? It is obtained by the cracking of ethane, and this is my ethane. So this is how you should be able to know the products of cracking the given alkane. Now with this clarity, let us move ahead to the different kinds of cracking. Now cracking can be of 2 kinds basically. So first type of cracking is the catalytic cracking. And second type of cracking is the non-catalytic cracking. Now, certain things to remember about the catalytic cracking is that the catalyst in this case, it will be SiO2 and Al2O3, that is silicon dioxide and aluminium oxide. Another thing about the temperature would be, the temperature is between 400 degrees Celsius to 500 degrees Celsius. And again, very important thing, what is the long chain alkane that is fed into the cat cracker? So they are the vapors of gas, oil or kerosene fractions. Okay, and about the non-catalytic cracking, it's important to remember that first of all there will be no catalyst. Next is temperature will be greater than 400 degrees Celsius and it goes up to 800 degrees Celsius. Okay, and with this kind of non-catalytic cracking, the percentage of alkanes is always higher. So you can get alkanes and alkenes, but you get large number of alkenes. Okay, so this is basic difference between the catalytic cracking and non-catalytic cracking. Now moving ahead to the actual process of catalytic cracking. So basically it's important to remember that there is a tank over here which is said to be the catalyst regenerator tank. Also, you have another tank in which the actual cracking takes place, and that is known as the cat cracker. Now what happens is, this cat cracker definitely will have an outlet for the cracked products to come out. So these are the small chained hydrocarbons, and from here the long chained hydrocarbons are fed. So you have the long chained hydrocarbons. Now what happens is, when the process begins and the long chain hydrocarbons are fed into the cat cracker, the catalyst that is present in the cat cracker, this catalyst that you can see here, which is a mixture of aluminum oxide and silicon dioxide, this catalyst starts to break down the long chain hydrocarbons that are coming here, and when they are broken down, they change into small chain hydrocarbons and they are collected from this part of the cat cracker outlet. Okay, this is all fine, but as the reaction progresses, it is found that the catalyst gets covered with carbon deposits, and because it is covered with carbon deposits, it becomes inefficient. It cannot carry out the process of speeding the reaction with efficiency. So what is done is, this cat cracker is connected to the catalyst regenerator tank. So this catalyst regenerator tank, the function of this tank is to free the catalyst of the carbon deposits, and the catalyst that is fed into the catalyst regenerator tank is said to be the dirty catalyst. So the dirty catalyst, it actually goes here. It gets into this catalyst regenerator tank, it becomes free of the carbon deposits, and it becomes clean like before. And when it becomes clean like before, it is again fed back into the cat cracker. So from here again it goes into the cat cracker. So this is how the catalyst is also recycled, nothing is wasted. So this is the way in which the catalytic cracking is done for the long chain hydrocarbons to be broken down into small chain, more useful hydrocarbons. So that's all in this video on cracking. I hope you like watching my video. Please do subscribe to my channel if you like. Also, another thing I forgot to mention, this catalyst that comes back here is called as the clean catalyst. Okay, you can mention it as Al2O3 and SiO2. Okay, so finally now, goodbye from my side. Happy learning.